In 11.3, we're going back to arithmetic sequences, but now we're going to use our recursive rule. So our formula, and you want to make sure that you have this down, a1 is your first term, and a sub n, so this is the rule, a sub n equals a sub n minus 1 plus d. So in words, what that is a sub n equals your previous term plus the common difference. So, given the first term and the common difference of an arithmetic sequence, find the explicit formula and the recursive rule. So we're going to start with our explicit, which we've learned already. So explicit. Remember that is a sub n equals a sub 1 plus d times n minus 1. So we plug in a sub n equals 15 plus 3 times n minus 1. 15 plus 3n minus 3. A sub n equals 3n plus 12. So that is our explicit formula. Our recursive formula, so recursive, that was a sub n equals a sub n minus 1 plus d. So with this, the only thing we really plug in is d. So a sub n equals a sub n minus 1. Whoops. A sub n equals a sub n minus 1 minus 3. However, we have to tell people where to start. So then we add on if a sub 1 equals 15. Now you absolutely need that if a sub 1 equals 15 or whatever your first term is, because we need to know where are we starting in order to find that rule, or in order to find terms. So here's another one. Split it up. Explicit. Recursive. All right, so a sub n equals a sub 1 plus d times n minus 1. All right, I want you to find what is that explicit formula. Okay, so I worked it out. If you did not get that question right, please take a look through those steps on how I got a sub n equals 7n minus 19. Now, our recursive rule, remember that's a sub n equals a sub n minus 1 plus d if a sub 1 equals. So go ahead and try and find it yourself. Okay, for this one, I'm going to walk through just how to do it again, because this is what we're learning. A sub 1 equals a sub n equals a sub n minus 1 plus 7 if a sub 1 equals negative 12. And there is your recursive formula. Okay, so determine if the sequence is arithmetic. If so, find the common difference and explicit and recursive formula. So same exact thing we've been doing, except now we actually have a sequence. So first, determine if it is arithmetic. Right? The sequence is arithmetic, and that common difference is 11, because they're increasing by 11 from each term to the next. So now find the explicit formula using a sub n equals so find the explicit formula using a sub n equals a sub 1 plus d times n minus 1. Right, this is what I got for the explicit formula. A sub n equals 11n plus 21. Where that first term comes from is right here, first term in our sequence. Right, now we're going to find our recursive formula. So reminder, that is a sub n equals a sub n minus 1 plus d. So for this one, a sub n equals a sub n minus 1 is, whoops. So for this one, a sub n equals a sub n minus 1 plus 11. Don't forget, if a sub 1 equals 31. Right, now we're going to figure out how to find the first 5 terms of the sequence. So finding our first 5 terms, we know what a sub 1 is, so we're going to take and put 12 in there to find a sub 2. So a sub 2 equals 12 plus 3, which is 15. So then a sub 3, now we take that 15, because it's our previous term, plus the common difference. 15 plus 3, 18. A sub 4, taking that previous term, 18 plus 3, that equals 21. And then a sub 5, once again, we take that previous term, so 21 plus 3 equals 24. So these are first 5 terms.